For standard 2.3, I chose to do problem 213 from the book. It says for a spin 1 system, show by explicit matrix calculation that the spin operators obey the commutation relations in equation 2.96. So let's talk about commuters. Commuters of two operators is defined as the difference between the products of the two operators taken in alternate orders. So here's the equation for a commuter. If the commuter is equal to 0, the operators commute. If it's not equal to 0, we say they don't commute. So here's the complete commutation relations from 2.96. And you see, since they are not equal to 0, then these operators do not commute. So now we'll show by explicit matrix multiplication and calculation that the spin operators obey the commutation relations. So for S sub x and S sub y, so you rewrite both of those operators in matrix notation, and we get that notation from the textbook, and we just go through and we can get to this point, and then we can factor out a 2i and sub in for S sub z, and we can write it in this form. For sy and sz as our operators, we write those as write in matrix notation and plug in our formula, which is right here. Go through and we can factor out, once we get to this point, we can factor out a 2i from the matrix, and we can rewrite this as this, subbing in for S sub x. And then for our sc and x operators, we sub into the formula again, right here. And use matrix multiplication, matrix subtraction, and we get to this point, and we can rewrite, well, first we pull out a 2, which is why we have a 2 over here in the denominator, and we can rewrite negative 1 and 1 as I squared and negative I squared, which just allows us to factor out I and sub in for the S sub y operator, and we get this. So you see that I have shown through explicit matrix calculation that the spin component operators obey the commutation relations in equations 2.96.